we have two objects. So we will apply force diagram or free body diagram if we have two objects, like in volumes or this diagram. So which kind of diagram we use? So we can say force diagram is consists of many free body diagrams, right? Home. Where's home? What's the difference between static friction and kinetic friction? Can you tell me what's the difference between distance and displacement? Distance is the whole distance. Okay. So what do you think, what is the differences between displacement and distance? Can you give me like, what's the main difference, and second, give example for holes that make our difference? So we can say the displacement for circle is equal to the vertical object will be set, right? Sure. What's the normal force, and how to get normal force if the object moves in inclined plane or inclined plane? How to get the normal force? Which component, for weight or gravity? Because weight and gravity are different, right? So which one? For weight or for gravity? Really? Normal force, right? So do you think gravity is a force? Gravity is a force, right? So what is the difference between weight and gravity? what is drag? So example, I said how to get y component for gravity for 9.8. So you would say 9.8 or yeah, gravity is 9.8. Due to gravity. What's the difference between projectiles and trajectory? And can you differentiate if the object moving horizontal line and the other one vertical? So what is the difference? Okay, so any object can. So this is projectiles, right? So which path will take which path will take this object? Circular or what? Parabola? Oh, okay, so which one? Like, okay, with that. Okay. So what's the trajectory? Okay, what's the difference between object move vertically and object move horizontally? Horizontal, X, vertical, Y. What is the difference in projectiles? Do you understand my question first? Okay, if I throw object vertically and object moving horizontally, so what is the difference between object fall vertically and object move horizontally? A move, yes.
The trajectory of the projectile horizontal is a move horizontal is
Okay. Thank you. Cecilia, what's the difference between moment and torque? Compare. Yeah, compare between them.
Actually, torque is
Is it same?
yes.
Yeah, since there's no any differences, we can't add a definition. Can you define both of them?
They are the same.
So it's the same definition?
Torque is another name of moment.
So, okay, so moment and torque is the same, even in definitions. We don't have any additionals like we can explain torque, right? We cannot say torque is a couple, right?
We can say torque, but torque of a
Couple forces. So what's couple forces?
a pair of forces that are the same in magnitude, but they are in opposite directions and they are parallel to each other, but they are not on one line.
Okay. This is right. Okay, thank you. Guys, we talked before torque, right? All of you look at the board. We study torque. Can anybody tell me what the meaning of torque? Yeah, what's the meaning of Iris? Okay. Torque is vector or scalar, and why? Vector, you think, right? Florence, what do you think about torque? It's vector or scalar, and why? Thank you. We will talk torque about different way. It's the same, it's not same, but it's a closer. But one is scalar, one vector. Yeah, torque is a scalar or vector. Why? Why vector? Torque has direction, right? Good. What about, did you study work before? Work. So work is a scalar or vector? Vector, right? Okay, thank you. Look guys, what we needed to know today. Actually, this chapter we will study work, energy, conservation of energy and power. First, what's the meaning of work? When we say what's the meaning of torque, we say is a force or turning effect of the force, right? Movement is in a straight line or horizontal? Of course no. When we make angular displacement, so turning effect, we have rotation. But work is the same as force, push object, okay, parallel to the distance. We call this is work. So work is a force time distance. But we have two things we have to know. First, what is work? When we say I do work, I use my force to accelerate object, right? So first things we have to know, what is meaning of work? First, we have two definitions for work. We can say work is not a product of force and displacement. What's the meaning of dot product? When we say work, W and letter W equal force dot displacement. How to say it? I think you took the dot product and the cross product, right? So we'll say force, distance, cosine theta. What is theta? The angle between force and distance. So how to define the work from this? We have two definitions. First, the dot product of the force, but I have to say dot. Because if I say the cross product, it will be F d sine theta, and this is what? Torque or moment, right? So, the definition of work, when I use force to accelerate object or to make it move a distance parallel to the force. So distance and force parallel to each other. So when we have examples here, we have force with angle 30, and I say, what is work here? I will say the work is a force that makes this object move a distance parallel to the distance. So force and distance are parallel to each other. So we'll say force times distance cosine theta. What is theta? Is the angle between force and distance. If I have force here, where's the angle? Where's the theta here? Of course, all of this if the object moves this way. So how to define work? I will say the dot product of the force and displacement. This is the first thing. The second thing, I say it is done by force when moves the object distance and pulls force and distance parallel to each other. So we have horizontal line or x-axis here. So examples, I have object now. If I ask, what is my work here? 0. First, no distance. But if I have two examples, two forces. The first object, perpendicular. Okay? The second force is here. And I say the object moved 2 meters. What is work here for close? What is the total work? To find the total work here, I have to find the result or resolutions for the force. First, I will example this is 100, this is 200. I will say force times distance cosine. What is the angle here? Example 30. You will say 30. This is the first one. This is F1, F2. So if work 1 equal F1 times distance cosine theta. What about the second force? What is the total work here? I will say W2 equal force 2 times distance cosine theta. What is theta here? 90. So cosine 90 equal 0. So if I have perpendicular and I have object pull this object, I have force to pull this object, all time weight and normal force, the work are equal there. Right? So now, what's the meaning of work? First, we have two definitions. Total product of force and displacement. The second one, it is done with the force accelerate object and move distance and force, both of force and distance parallel to each other. Parallel to each other. Is that clear? Anyone have a problem here? Julie, can you tell me what's the meaning of work?
Work is the not product of the force and distance and unit for work? What's the unit here? First, what is the unit of torque? So, if I ask, give me 3 units for work, what is the first one? Of course, from the formula, the newtons time meter. This is the first one. What is the second one? Kilogram meter square per second square, right? What is the third one? 1 joule. So, if I ask you, give me 3 units for work, of course, the SI unit, kilogram meter square per second square. The second one is a Newton's time meter, the third one is 1 joule. So now, we took the definition of the meaning of work. Now, what's the unit of work? Work is a scalar or vector? This is the question. Yeah, Edward, what do you think? Vector, right? Stand up. Tina, is vector or scalar? Iris, vector or scalar? Roy, vector, right? Ivy, vector or scalar? Vector, step. Tell me one. Yeah, tell me one. May I ask, energy, is it scalar or vector? What's the meaning of energy? Ability to do work, right? So, the proof is work is scalar or vector, right? So scalar, right? Why? Actually, look here. What is dot product? If we say cross the product, if we say sine theta or cross the product, we say this vector. So we say torque is vector, work is scalar. But why, if we don't mention this dot product, how to say work is scalar, not vector? Why? Sit down. Okay. Can you think about this? Why work is scalar? Sit down. And torque is vector. What is the difference? Another, we say first, work is dot product, right? What's the meaning of dot product? Is meaning when we have the force and distance parallel to each other. They have the same direction, right? What about torque? No. Torque is another thing. Torque we say all time is a cross product. Why? Because we say torque is equal force, distance, sine theta. What is sine? Distance, sine theta, we call this cross product. I think you studied that, right? So now, torque is vector, work is a scalar. And the big example for that, when we say what is energy, it is ability to work. So we have relative component between work and energy is a scalar, right? Do you think energy is vector? Energy is a scalar. Can you tell me why? Cecilia, can you tell me why? What's the difference between torque and work?
Torque is cross product of F and E sine theta. Work is the dot product of force and displacement.
So are you sure now? So work is a scalar, not vector, right?
Yes.
Okay.
I'm still confused.
Yes. We come back to the same point. Weight is scalar or vector, right? Right? Now if work, now when we use force, the force makes the object move a distance with direction, right? We have a specific direction. And we say work is a scalar. So what about weight? A lot of scientists, they say vector. Why? Because they say it is a force of gravity, and we can say this is, a lot of scientists, they say it is a scalar. So, after work, what do you decide? Scalar or vector? Weight is a scalar or vector? It's scalar, right? Okay, thank you. Guys, now we have 4 or 5 examples. Look at here, look at the board. The first examples, I have many forces here. The first one is 60 Newton with angle 35 degree. And the second force is horizontal with distance, F2 equal 30 newtons. Makes the object move distance 2 meters. And the opposite force, we have two examples similar but different in things. The first one here, this is the direction of the second force. But this is the direction of one force. So we have two forces here. So what's the difference here? So this is force. In this direction we have the F3 equal 40 newton with angle 30. The mass is 40 kilogram, distance 2 meter, mu k is 0.3. I mean, total work. Normal force, we got that before, and friction, whatever, static or kinetic. And I need it for all these examples. I think we have 14 minutes. I need for first one, second one, third, fourth, fifth. Okay? Try it. Yes. If you have any question, ask. Words, what do you think about words? Why is it? Okay. So easy, make it easy. What's the difference between distance and displacement in one direction? Yes, example. I see the object move in one direction 5 meters. What is the definition of speed? So velocity or vector is the same as magnitude of speed, right? So velocity and the speed means the object moving in one or specific direction are the same, right? So probably we can say the speed is a vector if the object move in one way, right? If the object move in one way, it doesn't change its direction, right? So take this one example. What's the meaning of a gravitational force? If G, we said all time what is weight is a gravitational force. We have two objects here, right? There is attraction force, like big magnet, small magnet. This is called the gravitational force. So the big one attracts the small one. So we have two directions. For the first object, attract like tension. Tension, so when I have tension between two objects. So for the first object, the tension is positive. For second, it will be negative, right? So we can say probably weight is vector if we consider we have directions, but we have, for the center of gravity, we have one specific direction. If I saw any weight, it will be to the center of the gravity. So the scientists say it is a scalar for this point. But they will not ask you, weight is a scalar or vector because there is confusion. First, the scientists say we have directions, so it is vector. Other people, they say it like speed. When I move, I have to speed, but if I say I move with a specific direction only, so velocity, like speed, displacement like distance. But if the object changes direction, This is indicates to vector, right? Do you understand? You're still confused, right?
Well, work.
Work is a scalar because it is dot product. This is known. Cross product is vector like torque. Dot product is a scalar like work. But now if we need mass, weight, how to find weight? How to find weight? Mass times gravity, right? If inclined plane, the weight will change. If in equilibrium, will not change. But other force will change according to direction, right? This makes the people confused. You can say vector, you can say scalar, according to your curriculum. In your textbook, what they say? Is it scalar or vector? They didn't mention, right? Because it's for some people, it doesn't look, we all time looking for the magnitude of weight, the magnitude of the gravitational force. Who doesn't need a direction because it's specific. This is what makes the scientists confused.
So, it has asked whether work is a vector or scalar.
No, they will not ask you work is a scalar or vector. All times they can ask how to find the problem. But work is a scalar because it is dot product. We know that. But for weight, this is something different. Some scientists, not professors in universities, say weight is a scalar. Everyone according to his orientation. Ayers, have you finished? Yes. Actually, guys, 1 second. How many force here? How many force here? If I ask how many total, I need it now total work. How many force we have here? The first one, F1, F2, weight, normal force, if this other one, and friction force, right? So we have to get all to get total work. Total work. You have to get normal force and weight opposite each other, and the total work equal 0 on both of them. NASA said a weight is vector. Cambridge, some of the scientists say it is a scalar. A lot of people confused about this point. If it come an exam saying it is vector y or scalar y. But did you read this, chapter 9? Well, I finished 7, 6, and 7, and 8. Oh, so you know Joule's law, right, Joule? Gauss' law. Actually, Coulomb's law is as similar as universal gravitational force. F equals G_m1 m2 over r squared is compared to force of the Coulomb equal kq1 q2 r squared. So you cannot write because this is basics. But the standard one, you use E equal V divide D to make it change to get F equal kq, capital Q small over r squared. So you cannot say how to drive Coulomb's law because Coulomb's law like universal gravitational force. Do you have a problem?
Yeah, the first one is
It's what?
the normal force is that the force, the total force.
Oh.
Yeah, it's totally more.
What is the normal force? Like
minus. Okay, we have another force.
Minus? This is, oh sorry, this is 40. Yes, big question. Guys, this is 40 kilogram. I do it here. Yes, this is 40. I didn't hear 50, this is 40. Because normal force cannot be equal to 0. This is, thank you, Stephen. And you forget something here too, the distance here. I forgot to write distance here is 4 meters. Distance here is 2.5 meters.
Guys, anyone finish the first one? First one. Not yet? class is over? How many one finished the first one? This is just for your fellowship. Of course, the second one only doesn't work. Guys, the answer for first one is negative. What about second one? Yes. There's no differential. So what is the word? Ready? Trash. Okay, guys, you can leave now. We can go to